How do you find the inverse of this function? How do you find the inverse? Remember, if two things are inverses, we know that they will reflect across the line y equals x. We also know if we take the original function and we look at the xy values, and we take the inverse and we look at the xy values, how are they going to compare? Turn to your partner. How do they compare? For instance, if I randomly tell you that the original function has the point 1, 3 on it, what can we say will be a point on the inverse? 3, 1. Remember how we're going to flip them? Okay, so these are things to consider. All right, here we go. So here's your first function. We're going to find the inverse. The first thing I do is I'm going to be lazy. I'm going to go over the top. I'm going to change this into y. Then I'm going to switch the x and the y. And now I'm going to solve, for the y, or I'm going to isolate the y. So to do that, I need to get rid of log base 11. This turns into an exponent, and this is the base exponent. What I do to one side, I must also do to the other side. Base exponent, cancels out, and I bring y equals 11 to the x. Now the original problem was h of x, so I write it as the inverse of h of x. And there is my answer. F of x equals 4 log base 5 of x. F of x equals 4 times the log base 5 of x. Okay, first thing, I'm going to go over the top and make this into a y. All right, then I'm going to change this and switch the x and y. And now I want to isolate the y. How do you do that? Well, this quantity is being multiplied by the 4, so to get rid of the 4, I'm going to divide. So x divided by 4 equals the log base 5 of y. Now to isolate the y, I need to get rid of the log base 5. This becomes an exponent, and here's the base. What you do to one side, you must do to the other side. Cancels out. Y equals 5 raised to the x over 4. And again, this original function was an f of x. Make sure to correctly write it. I can tell you that for the AZ merit, if they're grading how I suspect they will, if this is an f of x problem, then you must illustrate your final answer with the inverse of f of x. Can I have a thumbs up or thumbs down right now with your understanding? Thumbs up or thumbs down? Check with your partner before we try a harder one, please. Right? Okay, here's your next one. G of x equals the log of 1/7 x. First, I'm going to change the g of x into a y. Now I'm going to switch the x and y. To isolate the y, this becomes the exponent, and 1/7 becomes the base. Base exponent, base exponent. In doing so, these cancel. I bring down the y. 1/7 raised to the x. But my final answer needs to go back. Okay, this was a g of x problem. So the inverse of g of x is 1/7 raised to the x. Why is it important that I put parentheses around the 1/7? Because this x, which is an exponent, should be applied to this entire fraction. And if I don't, it looks like this, where it's only applied to the 1 on top. Okay, so make sure your fraction is in parentheses. All right, let's increase in difficulty. Next year, you're going to learn more about something called a natural log. So there is a number on your calculator that's called the E. It's a number E. And it stands for Euler's number. Euler's number. And it's a common number that's used in real life situations. And I will show you exactly what this is equivalent to. So do me a favor, like watch. If I do 7 to the first power, we know it's equal to 7, right? If I do 10 to the first power, we know it's equal to 10. Let's do e to the first power. How do you find e? Please go find the LN button on your calculator. And in mine, the e to the x is in blue. So do second ln and you will see an e. Do e to the first, and we can see that it is an irrational number, but it is approximately, e is approximately 2.718. And actually, it does look like it is repeating decimals here, right? Let me see if 1828, 1828. So in reality, this does look like it is irrational because we can predict the next number in the decimal sequence. Okay, so here's approximately Euler's number. And why is that important? Because mathematicians can be lazy. And please write down the letters L, N, and make sure that they are not capitalized. Sometimes they're capitalized, but a lot of times they're not. Ln stands for natural log. Natural log. And remember, logarithms are a way to rewrite exponents. And the natural log is actually equivalent to the log base e. So log base e is the same thing as ln. And I'm like, hey, we don't want to write as many things and then put an e in the bottom. So this is exactly the same thing as this. Exact same thing. Okay, here's our first problem. I'm going to flip this around. And let's go back to f of x equals 5 ln of x plus 2. To start with, whenever I see an ln problem, I'm going to ask that you rewrite it. What is ln equivalent to? Look in your paper. What's it equivalent to? Log base what? Log base e. So I want you to rewrite it like this now. Those are equivalent forms. Now we're going to make the f of x into a y. And we're going to switch the x and y. We want to isolate the y at this point. We want to isolate our y. So how do we do that? Well, I'm going to start by getting rid of on the outside. So let's get rid of the 5. 5 is being multiplied by this quantity. Let's divide by 5. So x divided by 5 equals log base e of y plus 2. Now don't be scared off by this letter e, because remember, e is really a number. It's approximately 2.718. So how do I get rid of the log base e? I take this number e and I put it down below. This is the base, this is the exponent. This is the base, this is the exponent. By doing so, it cancels, and I have e raised to the x over 5 equals y plus 2. The last step to isolate the y will be to subtract the 2 to the opposite side. E raised to the x over 5, subtract 2 equals y. So this is my answer, but what was the original problem in terms of? So the inverse of f equals e raised to the x over 5, subtract 2. Next problem. H of x equals 1/4 ln x, ln x minus 3. Okay, we see an ln problem, so our first step is going to be rewrite it as a log base e. And now think about, before I do anything else, I got to change the h of x into a y, and then switch the x and y. So on this side that contains the y, let's get rid of the outside. Some students forget, how do you get rid of a 1/4? It's a fraction being multiplied. What do? Multiply by the reciprocal, which is 4/1. The 1s and 4s cancel out. Remember, they really turn into a 1. And now I have 4/1 times x. So 4/1 times x is just 4x. In order to isolate the y, the next step will be to get rid of the log base e. Remember, e is a number. So take that number, Euler's number, and put it on the bottom, making it the base. Base exponent, base exponent. The e and the log-based e cancel, and I have e raised to the 4x equals y minus 3. Okay, last part, let's isolate the y by adding 3 to the opposite side. And this is my final answer, but go back to the original. It is a h of x problem, so the inverse of h is e raised to 4x plus 3. 1 through 5, your level of understanding so far. 1 through 5, being totally honest. Okay? There's one other type of problem. It's no more difficult than what we've been doing. Let's say m of x. So we have m of x equals 13 raised to the x power. We're still finding the inverse. Okay, so my first thing will be to switch the x and y. Remember, this is really a y. So x equals 13 will raise to the y. This is the reason why you need logs. This is the reason why. Why do we need logs? This is the reason why. The reason logs were invented is when you're trying to solve for a variable. In this case, what are we trying to isolate? There's no way to solve for a variable that's in the exponent position. Did everybody hear that? Without logs, we can't isolate and solve for y. That's the reason we have logs, is to solve for a variable that's in an exponent position. So what do? We're going to do reverse of what we've been doing. So if I go back here, do you see how in order to get rid of a log, I take this number and I make it the base? Does everybody see that? I'm going to do just the opposite. There's no logs here. So I'm going to take a log. I want to get rid of this so that y is by itself. So this is the number I'm going to focus on. Whatever I do to one side, I must do to the other. I'm going to write log on both sides. And whatever number I'm trying to get rid of, in this case it's the 13, it becomes the base. And I'm going to use a different colored pen just so it stands out for you right now. And then I write down exactly what I see. I see an x equals and 13 raised to the y. By doing that step, these cancel, and I get to bring down the y. I'm done. Y is isolated. Remember, this original problem is an m of x. Okay, next one. Let's do v of x. So v of x equals 5 raised to the x power. First, remember this is really a y, so I'm going to switch the x and y. Now I want to get rid of the 5 so that the y comes down. So I'm going to do log base 5 on both sides. And then I'm going to bring down exactly what was there, an x and a 5 to the y. By doing that, log base 5 and 5 cancel. I bring down the y. And I have log base 5 of x. But the original problem was a v of x. So the inverse of v equals log base 5 of x. 1 through 5, level of understanding. 1 through 5.